All right, the second example, if you turn your books to page 677, we're going to do exercise 20.3 on page 677, 1D. 1D says y equals x e to the negative x. And they want us to use the second derivative to determine the nature of the stationary points. So we need to find the stationary points and then use the second derivative test to state whether they're maxes or mins. Okay, so some of you probably didn't bring your book. I have a couple at the back on loan. Make sure you put them back. Carousel, listen up. Okay, so stationary points occur where the derivative is 0. So you can press pause, Mr. Wheeler, have the kids try this, and then press play to see if they got it. Welcome back. First derivative, product law. It's first times derivative of the second. The second is a composite function. First times derivative of the second plus the second times the derivative of the first. And that must equal 0 for a stationary point. We should simplify this a little bit. That's negative x e to the negative x plus e to the negative x. Algebraically, we can now factor out an e to the negative x. And I'm actually going to factor out a negative 1 e to the negative x because you'll see it'll help in our signs. Which gives us x minus 1. Now remember back to last year, what do we remember about e to the x as far as its possible roots? Well, you'll remember that, e to the x, which was an exponential growth model, had a horizontal asymptote at y equals 0, right here. So it did not contain any roots. So what I'm saying here is there is no value of x that you can substitute into that function that will result in a y value of 0. So there are no roots. So some students like to look at it this way. You can divide both sides by that e to the negative x, as it does not contain any roots. So you can do this. Okay, so negative e to the negative x cancels, and that equals 0. So we have one stationary point at 1. Okay. As you do these questions for the first time, I definitely encourage you to draw the original graphs and get yourself a visual for each of these values. So we have an SP1 at 1, comma, the function at 1. The function at 1 would be 1 times e to the negative 1. So we'll just write that, e to the negative 1. Okay. Let's double check that. That's 1 times e to the negative 1. Now the question said they want us to use the second derivative to determine the nature of that point. So the second derivative, f double prime of x. I'll go on to a new page here, actually. So, and I'll need that first derivative, as we will have to find the second derivative. So I will take a picture of that first derivative and bring it on to a new page. Okay. Before I find a second derivative, I'm definitely going to simplify this a little bit. Negative x e negative x plus e negative x. Second derivative. So we have a product here. Right here, there's a product. So there's first times derivative of the second. That's a composite function. Make sure you follow your chain law. That's negative 1, derivative of negative x. So that's first times derivative of the second plus the second times derivative of the first. Derivative of negative x is negative 1. Okay, so there's the product, and now plus the derivative of e to the negative x, which is itself, but don't forget, that is as well a composite function. So let's simplify that a little bit. Negative 1 times negative x would be positive e positive x e to the negative x minus e to the negative x minus e to the negative x again. And we have two like terms sitting in front of us. So we have x e to negative x minus 2e to negative x. There is the second derivative. We need it to establish whether the stationary point is a max or a min. So the SP from the previous page was 1 comma e to the negative 1. So let's double check that. That's right, I think. Yeah, that's right. So the second derivative would be f double prime at that input of 1. So, I was on the wrong page there for a second. So f double prime of 1 equals, in it goes. It's going into this second derivative. 1e negative 1 minus 2e negative 1. So as you can see, we can rewrite that as 1 over e minus 2 over e, and that results in a negative value. So recall that if the second derivative at the stationary point is in this case negative, less than 0, it must be a max. Okay, and you need to state that. So just to double check to make sure that the graph supports our findings, I want you to get in the habit of double checking these answers on your calculator. Okay, so here goes. I'll get the original function up there. Y equals, clear the screen. All right, the original graph was x e to the negative x. So that's second ln negative x. Graph. So we don't see too much of this curve because there's it seems to come up around 0 and then it goes back down again. I want to zoom box. If you don't remember how to do that, follow me now. I'm going to show you the keys that I press on the side here for zoom box. Press zoom, number 1, enter box. Take your left toggle switch right here. Climb up to the left, somewhere up here, up and left. Stop there, somewhere nearby, and press enter. Now take your bottom toggle switch, climb down to somewhere around here, and then to the right. And notice I'm actually creating a box over top of the curve in this area. I want to get a better look at this curve in that area because, as we found, there was a max at 1. So now if you have a rectangle drawn, press enter, and you'll get a better view of the curve at that area. Okay? So I'm going to ask the calculator for what it determines the max to be, just to see if we got our answer right. So press, notice the keys on the side of my calculator are there for some of you non-video game players. Like you, Amber. Pay attention here. Go second, calculate, maximum, number 4, enter. Climb this curve to the left, somewhere over here. Press enter. Climb this curve to the right. Notice it's asking me for a right boundary. I'm going to the right of the maximum. And press enter twice in a row. And the max is at 1 and a decimal place. And that decimal place is the same as what you guys got in terms of E. Okay? So I'm going to take that curve, go back to my original equation. There it is, and I want to label all of those points. So right here, let's put a smiley face because we feel so good that we got that question right. right there. And that point, that's a bit too big. That point is a max, and the max is at 1e to the negative 1. So 1e to the negative 1 is a max. That's what we said it was. Okay, so that's what the entire second part of that solution would look like. This question didn't ask us to find stationary points, but if it did, you would know what to do now. Okay. So your assignment today, the hand-ins that were due today, we'll hand those in on Tuesday. We have a test coming up on Thursday. I will post the review to that test online sometime this weekend. The next class, we're not going to learn anything new. It will be a review class. Okay, that's going to be on Tuesday. So make sure you print out the review sometime this weekend. Come to class on Tuesday with it. We will work on it and write the test on Thursday. But you have to get this one assignment done. Page 677. Okay, write this down. Riley, write this down. Page 677. I know you already have numbers 1, A, B, C done. But now I want you to do G. I want you to do 2, A, and C. And pay attention to the domain that they state to the side. It will affect what values you pick for max and min. Number 3 and number 5. Okay? These two curves here you should do on graph paper because they're sinusoidal functions. Okay? So you want your x-axis to be broken down into radians. So graph paper there. And don't forget, for today, you were supposed to have M53 all finished. If you had questions on M53, numbers 1 to 6, bring them to class on Tuesday. But some of you, if you're having trouble, you should be at extra help on Monday, folks, at 12:20. Okay, do not wait till the last minute. Okay, thank you.